In this question, we're first told that the weight of coffee in a glass jar, labelled 100 grams, is normally distributed with a mean of 101.8 and standard deviation 0.72. So, although the label says 100 grams, the manufacturer actually puts in a little bit more. At least the mean that they put in is a little bit more. Let's just get down this distribution. So, C follows a normal distribution, 101.8, 0.72 squared. To continue reading, the weight of an empty glass jar is normally distributed with a mean of 260 and a standard deviation 5.45. Let's get down that distribution. So the actual glass jar, 260, 5.45. Okay, we're then told the weight of a glass jar is independent of the weight of the coffee it contains. We're then instructed to find the probability that a randomly selected jar will weigh less than 266 grams and will contain less than 100 grams of coffee. We're asked to give our answer to two significant figures. Okay, so firstly, let's work on the coffee. So we want less than 100 grams of coffee. We can use our cumulative normal distribution and our arbitrarily small minimum value, negative 1000. The maximum we're interested in is 100. Standard deviation, 0.72. And the mean, 101.8. Okay, into our calculator, and we get our answer, 0.0062. So that's the probability that the coffee is going to weigh less than 100 grams. Okay, how about the jar itself, the glass jar? We want the glass jar to weigh less than 266. So now focusing on G, the probability that G is less than 266, arbitrarily small value, negative 10,000. 266 is our maximum we're interested in, standard deviation, and the mean, and that gets us an answer of 0.8643. Alright, what do we do with these two answers? Well, we've been told that the weight of a glass jar is independent of the weight of the coffee it contains. And we know that if two events are independent, I can find the probability of the intersection, the probability of both of them happening, the probability of both of them being true by multiplying them. The probability of A intersection B will equal the probability of A multiplied by the probability of B if the two events are independent. Okay, so here's how I'd write out that statement. The probability of both of these events happening is going to equal 0.0062 times 0.8643, and we get an answer of 0.0054. And that's our answer to two significant figures. So just being really careful here that you were able to use the fact that they were independent events, and that means we can multiply to find the intersection.